Good morning, afternoon, or evening, everyone. It's Mr. Mott. I'm going to go through the lab called Determining a Rule for Dissolving. So what we're going to do is going to go through several substances, and we're going to write down whether they're soluble in water or they're soluble in hexane, or possibly both. Okay, so we'll do this in the order that we're on page 34, and we're going to write down if it's S for soluble or I for insoluble in that solvent. In blue, the blue label are going to be, as we can kind of see here, we've got, let me get on the screen here, we've got water and we have hexane. Okay, so the solvent is water and the blue label, and for hexane it is going to be the yellow label. So as we can see here, we've got copper sulfate, and copper sulfate is going to be soluble, S for in water, and in hexane is insoluble. No matter how much we shook this or stirred it, the hexane would not dissolve the copper sulfate. So that's our first one, copper sulfate. Our next one is NaCl, otherwise known as table salt. And we should recognize, hopefully, that table salt should be soluble in water and insoluble in hexane. So S for soluble for water and insoluble in hexane. That's NaCl. The next one is going to be methanol. Okay, and for methanol is actually not normally green. We just dye it because it's easier to see. And methanol is soluble in water but insoluble in hexane. Okay. All right. The next one after that is urea. And urea is found in your urine, so we would expect it to be soluble in water, which it is. We don't see any solid in there. However, in hexane, it is insoluble. We see some undissolved solid in there, so we know it's hexane, or urea is insoluble in hexane. All right. Our next one we're going to look at is transmission fluid. Okay. So transmission fluid is red in color, and we can see that in water, transmission fluid is insoluble. We see a layer of it. However, in hexane, it is all dissolved. We have a uniform color there. It's all dissolved in hexane. The next one we're going to look at is NH4Cl, which is ammonium chloride. And we can see that ammonium chloride is soluble in water, no undissolved chemical. Okay. However, in hexane, ammonium chloride is insoluble. Next, we have ethanol. And ethanol is an interesting chemical because it is soluble in both. We see that we mix ethanol in water. It's insoluble in both. We don't have any layers, anything like that. Ethanol is a liquid. It's the alcohol found in booze. And our last one is naphthalene. Some people know this as mothballs. And we've got naphthalene here. We got some solid in there that will not dissolve in water. Okay. And then in hexane, though, naphthalene is soluble. We don't see any solids in there at all. Okay. Now, once we do this, we can look at our rule for dissolving. And so far, what we have is we have our results here from our lab, and we see that copper sulfate is soluble. So most of these things are soluble in water, but not in hexane. Water is a universal solvent, so it dissolves a lot of things. All right. And so what we have next is to discuss what is our rule for dissolving. Okay. Hi everybody, this is part 2 of our rule for dissolving lab, and these are our results for our lab. We said that S was going to stand for soluble and I was going to be for insoluble. Okay. Now, we want to remember from class that water is a polar solvent. It's one thing that we need to know. And that hexane is going to be non-polar. Okay, very important for our determining a rule about how things dissolve. Okay. Copper sulfate, CuSO4, is an ionic substance. We're going to go over how they're classified, either ionic, polar, or nonpolar. NaCl is ionic, and NH4Cl is ionic, and NaCl. Okay. Methanol is polar. Urea is polar. Transmission fluid is nonpolar. Ethanol is polar, and naphthalene is nonpolar. Okay. So once we have those results, what we're going to do is try to come up with a rule for dissolving. We're going to come up with 3 rules and then 1 rule that governs them all. Okay. So the first one is we notice, is there a pattern in terms of how our ionic substances dissolve? Ionic dissolves in water, which is polar. So ionic dissolves in polar. And we see that in all 3 examples, okay? That's going to be one of our rules, that ionic dissolves in polar. So we can go down here in this bottom part. Ionic dissolves in polar. All right? Now, what about all those things that are polar? What's the pattern there? Polar dissolves in polar. Polar dissolves in water, which is polar. Polar dissolves in polar. So down here below, we're going to write down that polar dissolves in polar. And lastly, we can tell from our results too that nonpolar dissolves in nonpolar hexane, and nonpolar substances dissolve in nonpolar hexane. All right, and so that nonpolar dissolves in nonpolar. Now, what we want to think about here is we've got 3 different rules to memorize, which wouldn't be too bad, but if we could remember 1 rule instead, that would be even better. So as we take a look at it, well, we want to remember that ionic substances have full charges, okay? So ionic, you want to remember, have a full positive and they have a full negative charge, okay? We also want to remember that things that are polar, they've got partial charges, partial positive, partial negative charges. And so when we think about polar dissolving in polar, things with partial charges tend to dissolve in those things that have partial charges. Okay, and so also we can remember and take a look at, well, ionic is similar to polar because they both have charges. So it looks like that these are chemically very similar. Okay, because they have an uneven distribution of those electrons. So what we can kind of say is that ionic dissolves in polar, polar dissolves in polar. Things that are nonpolar have no charges, so no charges dissolve in no charges. We come up with a rule called like dissolves like. And this is a rule that governs kind of all these 3 rules. And it means that things that are chemically similar will dissolve each other. Okay? Polar is chemically similar to ionic because they have either partial or full charges. Polar and polar are going to be very similar, obviously. And so is nonpolar and nonpolar. So our rule is like dissolves like in terms of our rule for dissolving. All right? So that's going to be our overall rule for dissolving, and it's a rule that we can use even if we don't know Even if we don't have the chemicals to mix, we can be able to predict whether something is polar or not, or excuse me, whether or not it will dissolve in each other. Thanks for watching.